All right, welcome everyone. My name is Kevin Libwit, and I'm here to talk to you about the most recent release of the Titan Illumina paired end workflow, version 1.2.0. In this video, I'm going to cover the highlights of this most recent release, and then afterwards, I'm going to provide a walkthrough of how to set up your Terra workspace to start using this updated version. All right, so first off, just to make sure that we're all starting on the right foot, I wanted to provide a bit of background. So the Titan Illumina paired end workflow is one of 3 Titan workflows for SARS-CoV-2 genomic characterization, with Titan Clear Labs and Titan ONT being the other 2. So the Titan Illumina paired end workflow, as the name implies, is meant for paired end SARS-CoV-2 sequence data generated on an Illumina platform. And from that input data, the Titan workflow generates SARS-CoV-2 consensus assemblies, provides metrics to gauge the quality of those assemblies, and provides some genomic characterization through Pangolin and Nextglade typing. This has always been the major function of the Titan Illumina paired end workflow, and so nothing about this core concept is changing in this release. The things that are changing include some minor changes to output headers. This won't impact anyone who's using the tool for the first time, but for laboratories that have been using the Titan workflows, we've made some changes in renaming a few output headers. Nothing about the files or outputs themselves are different, just the naming. This was done in an attempt to synchronize naming conventions with work being done at the Broad Institute, particularly by Danny Park. Our hope is that by utilizing the same language for these outputs, we can further increase interoperability of our works so that we can all take advantage of the downstream tools we're developing for things like report building and dashboarding. So after analysis is complete, you'll see these new output headers. I'll be making a follow-up video soon to show laboratories how to modify your current data tables to match these new headers to keep everything in sync and organized in your workspace. All right, and the second more significant change in the release is the bug fix regarding the ivar trim issue. For those of you who are unaware, there was a recent and critical issue raised regarding the StaffB Docker images for ivar, specifically those which contained Arctic primer bed files. Long story short, the bed files within these containers were misformatted, leading to primer regions not being trimmed prior to generating the consensus assembly. Once this issue came to light, we quickly updated this workflow to ensure that these Docker images were no longer being utilized, and instead updated the workflow to include the most recent and stable StaffB Docker image for ivar. This switch in the Docker containers, however, means that the bed file is no longer contained within the Docker image, and so this approach requires that users themselves need to provide a bed file for primer trimming. And so in the next half of this video, I'm going to walk you through the steps to first grab the appropriate bed file from the Arctic GitHub repository and then upload it into your Terra workspace so that you can start using it for your Titan Illumina paired end runs. Okay, let's hop into it. Okay, so as you can see, I'm now in my Terra workspace and I've got the Titan Illumina paired end workflow up and the most recent version selected. So you can see here that the first required input for this workflow is a primer bed file. And there are countless ways to use Terra to get the proper file uploaded as input for this workflow, but I'm going to walk you through what I feel is the most straightforward approach by first, downloading the proper bed file from the Arctic GitHub repository, second, uploading the bed file through the Terra uploader page, and then third, adding that file as an accessible workspace data element. Once you do this, you'll have that file available as input for every Titan run that you perform. All right, so let's navigate to the Arctic GitHub repository, and we'll be sure to add link to this page in the description below. Okay, so once you have the appropriate bed file selected, you're going to select the raw view. And once this pops up, you can right click and select Save As. And I'm just gonna go ahead and save this on my desktop, and I'm gonna go ahead and remove that .txt. So I'm gonna go ahead and select all files and hit save. All right, there you can see that file there, that primer bed file available on my desktop. Okay, so next is to upload this file through the Terra uploader page. So I'm actually gonna go ahead and save this page, and I'm gonna use app.terra.bio/upload. I'm going to go ahead and search for my Terra training workspace, and I'm going to select create a new collection. And in this, I can just call it Titan Files, for example, and create collection. And from this screen, I can actually go ahead and take my bed file and drag and drop it onto the screen. just like that. And once it's here, you can see that it actually appears as a link. This is actually a pointer to the Google bucket it was placed in upon upload. So what I'm going to do is actually copy that link location. So right click and select copy link address, because I'll need this to add it as a workspace data element. All right, so I'm going to go ahead and navigate back to my workspace, go to data and select workspace data. And you can see here that I don't have any workspace data elements currently uploaded, but if I go ahead down here and select add variable, in the key, I'm going to go ahead and type arctic underscore v3 underscore n cov dash 2019 underscore primers. And then in the value slot, I'm going to go ahead and paste the pointer to the primer bed file we uploaded. And then I'm going to go ahead and hit save changes. And so with this, we just created a workspace data element that we can input to the Titan Illumina paired end workflow. And again, you only need to do this once. So once you upload it here as a workspace data, you can reference it for every Titan run that you perform in the future. But first, after initially uploading this to the workspace data table, I need to sign off and sign back on to be able to access it. So I'm going to go ahead and do that, and then I'll show you how we can run this workflow from there. Okay, so I signed off and am back on, and you can see I have here a data table of paired N Illumina reads, and this table is my Illumina specimen ID table, and this is the data table that I want to run my analysis on. So let's go ahead, navigate back to the Titan Illumina paired N workflow. And so now for this, to insert that primer bed file, again, I'm going to go ahead and reference that workspace element. And so to do so, I can just start typing workspace, and you can see it pop up right there. And so for the rest of these inputs, you're going to fill in just like what you did before. So for read 1, we can do this dot read 1, read 2, this dot read 2, and then for the sample name, it's that Illumina specimen ID. And then for outputs, I'm going to go ahead and select use defaults and save. And now I can hit run analysis. All right, so things are queued up and already launching. So yeah, that's everything there. So I hope you enjoyed this video. This will be the first of many training videos on our Terra workflows. So if you have any questions or requests for specific training content, feel free to reach out to us directly, and we'll see what we can put together. I'll see you guys in the next one.